Hi, in today's video, we will learn about real life context of trigonometric function. And for that, I have taken a very popular problem, which is Ferris wheel problem. So whenever you're attempting a word problem of any math concept, it's very important to read the problem carefully and also highlight or underline whatever important information it offers. So let's read it together. A Ferris wheel moves with constant speed and completes one rotation every 40 seconds. So we know one rotation is completed in 40 seconds. The wheel has a radius of 12 meter, which means the diameter will be 24. Lowest point they gave us 2 meter above the ground. The height of a chair on the Ferris wheel above the ground can be modeled by a cost function, where t is a time in seconds. Find the value of A, B, C. The chair first reaches a height of 20 meter above the ground after p seconds. Find the angle at that the chair has rotated through to reach this position. Find the value of B. So let's do these questions one by one. First of all, let's understand how a Ferris wheel looks. You must have taken a ride of a Ferris wheel. This is image of the very famous London Eye. And you can see that a person sits here and then it goes around like this. Okay, around this wheel. So let's do this question. So for doing this question, first of all, I'm going to make a circle representing a Ferris wheel. So this is our Ferris wheel. You can always make rough diagrams while attempting the question. It just makes it easier for you to understand and answer. So this is our Ferris wheel. Now Ferris wheel won't be touching the ground, obviously. It will be at some height and the person will climb up that height and sit on the chair here. All right. If it is touching the ground, then the person's feet will be dragged. So obviously it will be at some height, and that height is given to us 2 meter above the ground. So the person who's taking a ride has to climb up 2 meters, reach here, okay, and up till here it is 2 meters. That's the minimum point or the lowest point above the ground. And the other information which we have is radius is 12. So if this is the center of the Ferris wheel, this distance is 12, and obviously the other side of it will also be 12, making it the diameter 24. Okay, so this total will be 24 here. So let me just represent this graphically. This is our lowest point. I'm just drawing a line at the lowest point. These are our x and y axis, the ground. So x axis and y axis. On the x-axis, we will have time because time is an independent variable. And on y-axis, we'll have function of time. In this case, it will be ht, which is the height. All right. Now, this is the middle. So a line should go through the middle. And there will be another line going from the top. Now, if you carefully observe, this height from here to here will be 24 plus 2. So it will be 26. From here to here, it will be 26. Let's carefully check the unit of the height given to us. It is given meters. So 26 here. And the one which is in the middle, so this is our 2. Now there's a line which is going from the middle, which is also called the equilibrium line or the midline or the principal axis, which is exactly in the middle of 2 and 26. And it is going to be at 14. So you can see equal distance from here to here. 14 plus 12 is 26 and 14 minus 12 is 2. So this is our principal axis here at y is equal to 14. All right. Now let's model this function on the basis of how the Ferris wheel is rotating. I'm going to use a blue color for this. All right. So a person sits on this chair, which is at 2 meter height above the ground. So that means starting point will be this. After that, like this, it is going around. He's going around and reaches the mid value. So next point, the mid value, going like this and reaches the top or the maximum point. So reaches the maximum point. After reaching the maximum point, the chair is going to come down. So it will be somewhere here, back to 14. And then finally, it will reach the lowest point once again from where it started. And this is going to be our motion of one rotation of the Ferris wheel, drawn graphically. Now, as given in the question, this will be covered, one rotation will be covered in 40 seconds. So, starting from here, which is at 0, to the end, or one complete rotation, it takes a total of 40 seconds. That's what we have in the question. That means this is going to be 40. Exactly the middle of 0 and 40 will be the highest point here, this point, which will be at 20. Now this point will be between 20 and 40, which is 30. And this is between 0 to 20, which is at 10. So 0, 10, 20, 30, 40, and we have model of function. Now question says represent this as a cost function. So let's start doing it. The expression which is given in the question or asked in the question we are going to find. For that, we are going to use the general form of cost function, which is y is equal to a cos b x minus c plus t. Now here different parameters have different meaning. A stands for the amplitude, which is always positive. So we can say that mod A, the value will be mod A. Here D is the vertical shift or the translation or the midline which we have got or the principal axis. C is the horizontal translation or horizontal shift. If there is any, we record it. And B is the value of 2 pi upon period. Now period is one complete rotation or one complete wavelength. No, horizontal distance of that, which is in our case 40 because this is our one complete rotation which we see on the x-axis here, or it's given in the question also. 40 seconds is when it completes one rotation. That's the period. So we can easily find now first B. Let's find first one by one A, B, C, D in the same order. So A is the amplitude or the maximum distance from the principal axis, which is 12. And as it is distance, so it's going to be positive always. So your A value is, mod A value is 12. I'll find B now. So B will be 2 pi. We just discussed period is 40 seconds. So 2 pi upon 40, which is going to be pi upon 20. After that, we'll look at D. D value already we have, which is at 14. This is our y is equal to D, the midline or the principal axis or the equilibrium. So D is nothing but 14. Now we need to see if there is horizontal shift. The Ferris wheel started from the lowest point. From there is no horizontal shift. If you carefully observe, it starts from the y-axis itself. So there's no horizontal shift. Your C value is going to be 0. Now using these values, let's frame the function. Now, if you remember, generally the cost function is going to be like this. Y is equal to cos x is going to be like this. It starts from maximum point or a minimum point, then go like this, and then it repeats. All right. Our function here is not starting from the maximum point. If it had started from the maximum point, it would look like this. the regular cos function, okay, the one which I'm drawing in yellow. So if you notice, the blue one is exactly the flip of this yellow function, which means reflection. So in our expression, I'm going to add a minus there. So I can write A is minus 12. Your amplitude is 12. Amplitude is 12. Amplitude is always going to be positive. And your A value is negative 12 in this case because of this mirror image which is formed for a cos function, the blue line which is the function for our question. So using all these details, our expression is going to be y is equal to minus 12 cos. In place of b, I can just put pi by 20 x minus 0 plus t. We need not write 0. So I didn't substitute for t, which is 14. Now I can just write it once again. Minus 12 cos pi by 20 x plus 14. Now this is our expression which they are asking in the question. And if you want to write it in terms of h and t, so h of t or the height, function of height is minus 12 cos pi by 20t plus 14. This is our answer for A part. And for the A, B, C, which is asked in the question, we can write our A is minus 12. B is, in this case, we have to just compare with our final answer, which is pi by 20. Here, if you see, it is plus C. So whatever I'm having as plus here, which is 14, I'm going to write here C is 14. This is the answer for first part. Now let's answer the second and the third part. The second part says, I hope this is clear. If some part of it you want me to repeat, please add your comment in the comment section. I'll try to just give you further reasoning behind it, or we'll redo it and I post another video for this. So now let's answer the other questions which are asked. B part says, find the angle that the chair has rotated through to reach this position. So let's look at B. Now, when they say angle, the angle in this case is this. Next to cos, what you see, that is the angle, because cos of 30, cos of 40 in terms of degrees, or cos of pi by 20 radians, or pi by 40 radians, whatever it is. So this is our angle which we have to find in the B part. And they have given us the height. So I'm going to just substitute the height and find the angle. After that, going to find the value of time, which is p in our case. All right, so let's go ahead. So height is 20. So I'll just plug in, substitute height as 20 here, is equal to minus 12 cos pi by 20 times t plus 14. Now if it is a GDC paper, you can just simply plug in this expression in your GDC and get the answer using solvent. If it is a non-GDC paper, then I'm going to tell you what to do. You try to make this as the subject of the formula, the angle, because that's what they want. So make this as the subject of formula, which means let's shift everything else. So 14 comes next to 20, it becomes 20 minus 14 is equal to minus 12 cos pi by 23. This will be 6. Now I'm bringing negative 12 down below 6. So 6 upon minus 12 as cos pi by 20t. This will be negative half is equal to cos pi by 20t. Remember, I'm interested in angle, which is this green shaded area. So eventually this should be my subject. I'm going to now shift the cos there. So if I shift cos there on the other side, I'm going to get cos inverse of negative half is equal to pi by 20t. All right. Now cos inverse negative half should be easy to find, because These are the angles you are expected to remember. So if you remember the basic angles which we have to remember is 0, 30 in degrees, 45, 60 and 90. And for cos, cos 0 is 1, cos 30 is root 3 by 2, cos 45 is 1 by root 2, and cos 60 is half, cos 90 is 0. This you got to remember. All right. So, but we have to find the angles in terms of radians only, not in terms of degrees. I just wrote because this is what normally you learn from grade 9 onwards, these values. So let's go further. It's going to be pi by 20t is equal to, now you see your half is next to 60 degrees, but it is negative half. And for this, you have to understand the quadrants once again. First quadrant, second quadrant, third quadrant, fourth quadrant. We can divide the angles into 4 quadrants. This is 0 to 90 degrees, 90 to 180 degrees, 180 to 217 degrees, and then back to 360 degrees, which is also our 0 from where we started. So this is, it works like this, all silver teacups. Easy to remember acronyms. So A for all angles are positive in first quadrant. Only sine, S for sine, silver, sine is positive, tan is positive, cos is positive. So our cos negative half should be somewhere here in the second quadrant or the third quadrant. Okay. So I'm going to take the second quadrant, and for second quadrant, I can remember it as cos 180 minus theta, which is minus cos theta. So in our case, I want negative half. It's going to be minus half here, right? That's what we want here. Negative cos theta, that's the value, negative half. I can write it as minus cos 60 degrees. That means our theta is 60 degrees. So this can be written as cos 180 minus 60, which is nothing but cos 120. So cos 120 is nothing but negative half. And if you want to visualize it as radians, you know that pi radians is 180 degrees. So 120 degrees will be pi times 120 upon 180, which is, you can just simplify this. This is in case you can't figure out directly. I'm just giving you a quick method. It will be 2 pi by 3 radians. 2 pi by 3 radians value, and that will be the answer because cos, we wanted pi by 20t and we just got it. Pi by 20t, which is our angle, is 2 pi by 3 radians. We have to be very careful because in this question we are dealing with radians, so we got to write the final answer in terms of radians. If it is not mentioned, then you can use degrees or radians, whatever works. So we have the answer for the angle. In terms of degrees, it's going to be this, and in terms of radians, it's going to be this. Depending on the question, you can write your answer. Now, the C part. Now, they're asking find the value of P or at what time it happens. So, in our expression, if you can see that we already have pi by 20t is equal to the last step of previous part, which is pi by 20 is equal to 2 pi by 3 radians. All I have to find here is t, because at what time this happens. So I'm going to just shift this 20 there, pi there. It's going to be times 20 upon pi. You can just cancel whatever you can. So the answer is 40 upon 3. You can write it in decimals up to 3 SF because that's what IB expect, 3 significant figures. So 3 ones are 3, 3 threes are 9, then again 3 threes are 9. Now we are getting a recurring decimal here it's going on. So the final answer can be written as 13.3 seconds. We have answered all three parts of this question and I did it without a GDC, the entire question. In my next video, I'm going to show you how to use a GDC for this question. So stay tuned. Please comment GDC solution as well so that I can share my next video in which I show you how to solve it without a GDC. Until then, bye bye.